Hello students, today we are discussing other principles of the green chemistry. In last session we see the first 6 principles of green chemistry. So in this lesson, in this lecture we see another principles. So let's get start our interaction. First is the use of renewable feedstocks. Next is the reduced derivatives, catalysis, design for degradation, real-time analysis for pollution prevention, and last one is inherently safer chemistry for accident prevention. So we see one by one. So in use of renewable feedstocks principle, the principle of this is towards the petrochemicals. According to this, use chemicals which are made from the renewable sources rather than other. For example, over-exploitation of non-renewable feedstock or sources puts burden on the environment by depleting the resources and future generation deprive. Use of renewable sources does not put much burden on environment, and products and waste are generally biodegradable. For example, agricultural or biological product ensure the sharing of resources by future generation. Next we see the reduced derivatives. In that, unnecessary derivations, that is blocking group, protection, deprotection, temporary modification of physical chemical processes should be avoided whenever possible during the chemical synthesis, because such step require additional reagent and can generate the waste. The green chemistry principle aims to develop the methodology where unnecessary steps should be avoided and atom economy also less. For example, in synthesis of meta-hydroxybenzoic acid from meta-hydroxybenzaldehyde, there is use of protection of some functional group. Finally, again we need their deprotection. Next we see the catalysis. In catalysis, in chemical reaction, use of catalyst speed up the rate. Catalyst helps to increase selectivity, minimize waste and reduce reaction times and energy demands. Next we see the design for degradation. Design chemicals that degrade and can be discarded easily. Ensure that both chemical and their degradation products are not toxic. The aim behind this principle is that the waste product should degrade automatically to clean the environment. Thus, the biodegradable polymers and pesticides are always preferred. To make separation easier for the consumer, an international plastic recycle mark is printed on large items. So, some items which we used in our day-to-day life. So, if you observe some bottles or some materials, some plastic materials or other glass materials, etc. At the bottom there is the recycle mark is printed on large items. That is, here you see, for example, at this bottle or container, at the end of this or at the bottom, here the PETE, that is here one triangle is present, and in that triangle one is written. This sign is for the PETE. Then some bottles like shampoo bottles or other bottle, if you observe at the bottom, here the print of like that means triangle is there, and this arrow shows the recycling. So these bottles are recycled. These arrows is nothing but they say about this product is recyclable. And 2 means HDPE. HDPE means the material name, which material is used to produce these bottles. So we see some examples. Some picked community use food, drink, container and packaging. If you observe this sign in triangle, one is there, and here if one is there, then PETE is written. So what is the PETE? Polyethylene tetraphthalate. So this is commonly used for food, drink containers and packaging. Easy to recycle, pick up by community and curbside programs, and they do not reuse. Okay. If this sign triangle and in triangle 2 is there, and write at the bottom HDPE. HDPE means high density polyethylene. Commonly used for the soap containers, insulation, helmets, pipes, plastic, lumber, etc. Easy to recycle, pick up by community, and it is totally reusable. Next, in triangle, here 3 is there, and at the bottom PVC is written. So what is PVC? Polyvinyl chloride, and this commonly used for the furniture, clothing, medical supplies, etc. Difficult to recycle, not accepted. Do not reuse for food, drinks or children toys. Next, if in triangle 4 is there, at the bottom LDPE is written. So what is LDPE? Low density polyethylene. So commonly used for machine parts, lids, trash bags, etc. So difficult to recycle, few facilities accepts its reuse on your own as much as possible. Next, this is the triangle again, and in that 5 is present, and at the bottom PP is there written. So what is PP? Polypropylene. Commonly used for the clothing, surgery tools, packaging tapes, bottle caps, etc. On that, these stamps you observe, and PP is also observed, polypropylene. So check your local curbside facilities, not commonly accepted, but they are the reusable. Again, these stamps, the triangle in triangle 6 is there, and PS is written. So what is PS? Polystyrene. So commonly used for the disposable food, drinks, containers and packaging materials. Difficulties to recycle, few facilities accept it, but they do not reuse. And last one is the 7, so it is the other. So used for the variety of items, sports equipments, baby bottles and electronic parts, which are difficult to recycle and they do not reuse. So this is all about some products at which this type of stamps is there. So you have to choose reusable stamps products. Next is the real-time analysis for pollution prevention. In that, analytical methodologies should be developed or modified so that continuous monitoring of the manufacturing and processing unit is possible. This is very much important for the chemical industries and nuclear reactors. Last is the inherently safer chemistry for accident prevention. In that, we need to develop chemical processes that are safer and minimize the risk of accidents. Substances and the form of substance used in chemical process should be chosen so as to minimize the potential for chemical accidents, including release, explosions and fires. Last, we see the role of green chemistry. The green chemistry helps to reduce capital expenditure to prevent pollution. Green chemistry also is a new way of looking at chemicals and their manufacturing processes to minimize any negative environmental effects. Also, it helps to protect the presence of ozone in stratosphere, which are essential for the survival of life on the earth. Green chemistry is also useful to control greenhouse effect. It promotes pollution prevention practices in manufacture, use or generation of hazardous substances in the designing chemical technology. So, lastly, I would to say save environment and save earth. Thank you.